Λοιπόν, γεια σας. Καλώς ήρθατε. Τώρα μόλις αντιμετωπίσατε μιλώντας μαζί με τον Γιώργο Κορίνη, είναι και το τελευταίο πρώτο του καλοκαιριού, τα μπάνια του λαού, τελευταίο μήτα. Έχουμε σήμερα δύο παρουσιάσεις. Μία είναι ο Jeremias Rößler που θα μας παρουσιάσει το ReTest. Περισσότερο θα μας πει ο ίδιος και μετά είναι και η αρετή πάνω με μια εξαιρετική παρουσίαση. Λίγο δύο διαδικαστικά. Πρωτού ξεκινήσει το δεύτερο μέρος, θα μας πει λίγο πάνω από τις hooks, δύο πραγματάκια που ψάχνουν, υπάρχουν κάποιες ανοιχτές θέσεις εργασίας. Και στο τέλος θα κάνουμε και μία κλήρωση για δύο φίλοι για το Debit. Και στο τέλος το κλασικό, πίτσας και μπύρες και networking. Λοιπόν, καλώς ήρθατε και απολαύστε το.
So, hi Jeremy.
Hi.
Oh, great, great. Can you hear me?
I can hear you great. Can you hear me?
Okay, excellent, excellent. So, you can start. I think we are here. Oh, just a moment. I have to switch your picture to our projector. Oh, perfect. So, we can see you. And can you share your screen, please?
Yes, of course.
Okay, awesome.
Okay.
Okay, perfect. So, I think we're here approximately 20-25 persons. So, the stage is yours.
Thank you very much. And thank you very much for inviting me. I'm very excited about this. This is the first time I'm doing a presentation via Skype. And I hope it works everything. Technically, looks good so far. Let's see how far we get.
Perfect.
So, when talking about AI in testing, people often think that testing is easy, so it should be easy to use AI to do the testing. And for that, since I guess there are some testers among you, and those who are not testers probably have used software in the past, so I think you can probably answer the question whether this value is correct or not. Well, if you think about it, it's actually a hard problem to answer, or a hard question to answer, because you don't know the software, you don't know the data that went into the software, you don't know how it's configured, so you have essentially no way of knowing whether the given value is correct or not. And AI, frankly, is in the same situation. AI, when it wants to test another software, first has to understand the software and the context in order to be able to give a correct answer to that. Generally, this problem is called the Oracle problem. Oracle problem is a pretty fancy name for such a seemingly trivial problem. And the reason why it got such a fancy name is stems from actually Greek mythology. And if I could come up with a general oracle that could answer for any given software, whether it's correct or not, I could just write a 3-line program that always returns no and ask it, does God exist? And then in order to correctly tell me whether my 3-line program, when now it returns no, is correct or not, the oracle would actually have to know whether God exists or not. And as you can imagine, this is a pretty hard question to answer. So this is the reason why it's called the Oracle problem. Any question, any problem can be turned into the Oracle problem via such an answer or such a question. Which means that the Oracle problem itself is the hardest problem there is. If we can solve the Oracle problem in a general way, we can solve any other problem. So in case you're a tester, now you know that you are working on the hardest problem of humanity all day long. So, but maybe our software does not want to answer whether God exists or not. Maybe we want to answer a simpler question. Maybe we just want to know whether this value is correct or not, well, it still turns out that this is very hard, even seemingly trivial problems, this is a very hard question to answer. And if we could come up with an AI that is strong enough to understand software, because this is what it means, right? In order to be able to tell whether the value is correct or not, you have to understand the software and what it's supposed to do. And if we can come up with an AI that is strong enough to do that, then it would actually make more sense to have that AI generate the software instead of letting it automatically test a manually created software, right? So my best guess is that this will never happen. Once AI is strong enough, we will just use it to generate the software in the first place, and testing will be obsolete in terms of the understanding of AI. Still, I'm talking about AI in testing tool. So what can I talk about? Well, turns out the Oracle problem is like thinking that the world is flat. It's like you can't sail, you can't reach India, America for that matter, if you think that the Earth is flat. But if you change your point of view, then you suddenly realize that maybe the Earth is not flat after all, and then it's easy to get someplace, to get to India or to get to America. So how can you do that? Well, if we don't try to bring AI into testing, maybe we could try to bring it into test automation. And it turns out that test automation is a whole different problem. Did you know that test automation mostly is regression testing? And did you know that automated regression testing isn't actually testing? Because when you test, you want to find problems in the software. But if there is an issue in software and it's been there for 3 years and the customer has been using the software anyway, then you don't really care about that problem, right? So regression testing does try to find problems that are in the code. Regression testing tries to guard you against unintended side effects. So if you change the software, you want to make sure that your change doesn't break existing functionality. And in that automated regression testing, it's actually more comparable to different products, which we call version control. If you think about version control, I mean, this is an existing system, right? We have this since the 90s, starting with CVS. Version control manages your static artifacts. So if you have a code file, a Java file, or a configuration file or something, then version control can show the history of that and can manage the changes. But what we actually want, version control now, is not static artifacts. We want the dynamic software. And if you think about it, the dynamic software is much more than the static artifacts. It's data that goes in, it's a configuration, it's a runtime system. So it's created by these artifacts. But as you all know, probably, a slight change, just a one-line change, can have tremendous effects on the runtime, the dynamic behavior of the software. So although we want version control of the software, what we get up until now is only version control of the artifacts like code. And automated tests, if you think about that, close that gap in turning your automation, your dynamic behavior into static artifact. Because a test, a written test, a programmed, whatever, Java test or Selenium test or whatever you talk about, is actually software behavior turned into artifacts that you can govern it with existing version control systems. So let's have a look about how effective that is. The go-to mechanism when testing code, any code usually, are assertions. And here you have a simple example. So it's an XML transformer that's supposed to remove the parent No, sorry, that's remove tag from the parent tag and keep the keep tag. So this is the XML that goes in. The remove tag should be moved and the keep should be kept, right? So this is what happens here, and this is how we assert it. We say in the result, the remove should not be contained, assert false, and the keep should be contained. And this is what we expect. So, like, this is what goes in, and this is what should come out. But the problem is the way we code it test is we actually only check a keep is contained and remove is not. So that XML, or not even valid XML, make the test pass. Now, of course, we can come up with a lot more assertions to check each and everything, but that really doesn't make sense, right? Because we have a very clear expectation. We know what we want. This is what we actually want. Very clear. So what we could do instead is we could save that thing, that result that we expect, and compare against this. And that kind of testing exists since a long time, like 4 years, and it's called golden master testing because of the golden masters that are used to create the audio recordings, to create the records in earlier days. And there are existing tools for that. For instance, if you want to do it on the unit level, there's approval tests that does just that. So we use that in our earlier test. We just say approvals, verify XML, and now the created result is persisted, and you run the first time you run the test, it fails, and the result is persisted. The second time you run the test, it verifies that the output didn't change. So that way, if only single character changes, even if it's just a white space, you get notified of that. And if you think about that, like, you can still say, okay, isn't candidate changed? I changed the software now, the result should be different. So, if you think about software testing like that, or testimation like that, then it's actually blacklisting changes. So if you do assertion-based test, blacklist changes. But still, if the test fails, you might adapt the assertion. And now with golden master testing, whitelist changes. Would, for instance, say, I don't care about the white space characters, like whatever. White space doesn't I'm not interested in what space does. Could be tabs or space, I don't care. So you have to whitelist those changes and allow those changes to occur without the test to fail. And there's an ideal amount, right? So some things are allowed to change. There are volatile things in the output, build number, the date, time, stuff like that. So there are things that you say I'm not interested in, and you have to witness them. Or blacklisting means essentially if you don't put any assertions in your test, then you don't take any, right? So you have to put in some assertions, and the ideal amount is somewhere in between. But if you think about that, blacklisting versus whitelisting, you probably also know that firewalls, for instance, and there, blacklisting is considered not a good approach. Like that. Well, because you want to err on the side of caution. Like, for instance, at Google, they use this unicorn here to mark changes that should be scrutinized by the tester. So if you are a tester working at Google, then at some point you see such a unicorn, you know that this functionality was changed and that you need to test that very extensively. However, it turns out that at some point the engineers forgot to remove that marking. So the actual customers at some point had those unicorns dancing on the screen. because someone forgot to remove the marking, and there was no automated test that says, is there a unicorn dancing on the screen? Which obviously is the first kind of test that you would codify, right? So what this means is that you can't check for unintended changes. You can't, like, you wouldn't write an assertion for everything that's possible, right? So, therefore, if you do whitelisting and something unexpected happens, then you get notified. Then you get a failing test that says, oh look, there's a unicorn that wasn't in the expected outcome. What should I do with it? You could still say, I don't care about unicorns, let's whitelist that, and in the future we can have dancing unicorns. Or you could say, oh, I forgot to remove that. But if you come from the blacklisting approach, you would have to actually actively put an assertion in your code, check for the unicorn, or otherwise you won't know if it occurs. And there's something else that we realized is that usually you want to check more rather than less. So the ideal amount of checks usually is more tilted to whitelisting. So you should better start there. So the example that I gave now is an XML example. How about how about your website? Well, same thing. You want to test check rather more than less. So you would want to create some sort of copy of the outcome and check what changed. And if you do that, it turns out you have another advantage, because usually when you create a test, you have to rely on some sort of identifying attribute. For instance, if you create tests like a Selenium test for a calculator, you want to use names and IDs to use the buttons to tell the test to press the buttons, right? And if those IDs change, the names change, then your test will break, which means that test will say, I don't know which button to click, although the software under test still works. Well, if you create a copy of everything, then you can use that copy to find that button in your gold master, in your copy, and then find the best match to the actual site. You can use, because now you created a gold master, you persisted all of those things, now you can use all of those things, all of those attributes, like the path, name, the ID, whatever, coordinates, classes, whatever, to find that element again. And it's even better, because you not only persisted that one element, you persisted all elements. So you can see what element tests the best overlap, the highest match. Just use that element to find that button, that input box again, and have your tests not break. Now I have a short demo for that. So this, what I'm going to show you now, is an open source, that you can just download and use. It's called ReTest Web actually. So here I have a typical impulse. As you can see, I find elements by name and ID. If I execute that, it should execute just fine. As you can see, we're inputting some stuff into the fields. And it's the first time I run it. So the first time there is no golden master, so the test doesn't know what to compare against, so it fails. So I run it again. This time it compares against the golden master. Nothing changed, so the test. Now I can actually change some things. I can change some text. What is a good text? So if I run the test, it fails and says that I changed this text, which I did. Now, what is interesting, I can even now, here I'm using ID and name. Now I can change that. I can even remove it completely, and the test will still execute. Now, if you look at that, the test will still find the corresponding box. And input field. That's a bit slow now, I don't know why. Okay, it's still executed. As you see, it just gives me the change. It just says, okay, this ID changed and name changed, or this other ID also changed, and still the test executed. So we can get tests that don't break as easily. Actually, you can use a virtual ID, so you can use a ReTest ID that doesn't even exist on the actual HTML. It only exists within the gold master, so the test never breaks it. So internally we call this unbreakable selenium. And it also solves another problem that usually you don't, like, you can have complex selectors, you know, to reach the element that you want to address. And now, in the ReTest ID, you can just give it your own ID. Again, it doesn't occur on the HTML, so you can give any ID that you want, and your test still works. This is open source, by the way. You can download it and try it, and we'd be happy to get feedback on that. So, but what does all of that have to do with AI in testing? Well, as I said earlier, we have the Oracle problem. So the AI doesn't know what the correct outcome should be. But as I just said, you don't need to know, because we can just use test automation like a version control system and make sure that we don't get unintended changes. And for that, you can now use any, like, you know, probably know monkey testing, which is the basic idea is that you have the monkey hitting keys at random. And if you do this for a long enough time, like you do this for eternity, eventually it will write Shakespeare. And now monkey testing is just replacing the typewriter with a computer and the monkey test. And this already solves the problem of generating perfect tests. Like the monkey can write Shakespeare, it can also create perfect tests for you. It might just take eternally long. So what we do now is we use AI to speed up the process, right? If we use AI, we can get good results in less time. And we do that by, like, you have such a complex input screen, and you probably have different, the fields depend on one another. So you can only input a certain value here if you input a certain other value there, stuff like that. The easiest instance of that problem is actually a login field. If you enter a certain username, then you have to enter the matching password. And this is very hard for AI to find out by. If you give it long enough time, it will brute force the problem and solve it, but it's easier to train it actually. So what we do is, and also if you have a complex process, like a user in an ERP system, you know, creating a transaction, entering numbers, whatever. So it's a long process, and the AI will probably take some time finding out how that works. So what we do here is we take a similar approach to driving. Like if you want to create a car that can drive autonomously, then you have the problem that you need to, and you want to do it visually, then you have the problem that you need to recognize where you are on the streets, you need to recognize where there are obstacles, you need to recognize traffic signs are there, like are you allowed to go left or right, or what's the speed limit, and you need to understand that there are traffic lights, and which of those traffic lights is for you. And you need to do all of that in real time, because it doesn't help you if the AI says, oh, there was a traffic light 200 meters and we just crossed the junction, right? So how can we do this? Well, actually today we can't. This is too hard a problem to solve, even for Google's and the like. So what did they do? Well, if the problem is too hard, maybe you can't find a smaller problem and then reduce them to that problem. And this is what Google did. You probably know Google Street View, Street Maps. What they did is they took photographs of each and everything, terabytes of photographs. And then they could analyze that offline with all the power of Google, of the Google Cloud, with so much processing power. And then they correlated that with GPS signals. And now suddenly the problem becomes a lot easier, because you already know where you are, you know how many lanes there are, you know how fast you may go, whether there's a one way or not. Now you only need to find obstacles, and you already know that there's a traffic light. Now you need to only find it, and you already know roughly where it is in the image, so you now only need to find it and decide whether it's red, green, or yellow. And this you can even do today. Now we can do the same thing for our AI automation project. If that process is too long and too complicated and the AI can't figure it out on its own, we just create a recording. We just record what happens and give it to the AI. Then the AI, the monkey, can just test all the things that different. It can go back, it can enter different state, it can enter a different name, it can see tap this different button, stuff like that. So it tests all different user scenarios that real user at some point would also come up with. And if you give it the code to analyze, it can even test more thoroughly than a manual tester, because it can do white code analysis, white box testing. So it can, for instance, if you have a birth date and you only want to know, so in the specification it only says birth date existed, and it doesn't do anything with it. But the monkey analyzing the code knows that it actually makes a difference which birth date you enter. So it can, test all the different possibilities that it knows about by analyzing the source code that a human tester would do. So going back to our original example, the AI won't be able to tell whether that value is correct or not. But after a human has tested it once, then the AI can make sure that if the developer changes something, that value doesn't change as an unintended side effect. We can even use an artificial, so we can use different AI approaches and combine them. We can have an artificial neural network that is trained how software works in general. How a typical user uses a typical software, and not train a specific software, but on design principles, like larger buttons are much more probable to be clicked. Buttons that are close to another are much more probable to be clicked, stuff like that. So we can train the AI on general design principles, and then, such as said, record individual small examples. So you probably think that for most of AI you need a large number of training samples, which is true if you talk about artificial neural networks, but algorithms, you just need for one recording. That suffices. And then you can combine the two by training just a couple of use cases, and then the AI can test your software. And there's already, this is the beginning, right? There's already this has already been done. For instance, like we do this, we're a startup, we do this, but others do this as well. For instance, at Facebook, there's a software called Sapiens, and fortunately, this is not a product that you can buy, but within Facebook, software is used to test all of the Facebook products, like all of their apps are tested with Sapiens. And as I said, it just works like that. The user tests a certain function, then you train the monkey. You can even combine that, right? While you test the software manually, you can record the testing and train the monkey. And then you can use that training to automate the software tests. And then if there is a change, the developers, like before the release of this version, you have your automated tests, find all the differences, and then because of the Oracle problem, still a human needs to check the difference. You still need a human in the loop to check what changed, and this was an intended change or an intended a regression. So, this is how AI can be used not for testing, but for test automation. Actually, when I talk to people, I always tell them, as I said at the beginning, that AI will rather replace developers than testers. And this also already has begun. Like at Facebook, they use Suffix, which is a successor of Sapiens. And for simple problems, null pointer exceptions, stuff like that, out by one errors, index out of bounds errors, stuff like that. So simple tech problems. And this software can already generate fixes. And using tests that generate it can ensure those fixes doesn't break anything else. And in that case, everything else works as expected, but the bug is fixed, and it can apply the fix. What you just saw is just the beginning. Like 20 years ago, 30 years ago, the internet looked like, right? It's very basic, it's very primitive. But if you compare it to the internet we have today, you realize that we've come far away. And you will see the same happening AI in test automation and in automated development. So this is already my talk. Do you have any questions?
Thank you, Jeremy. Have anyone some questions?
Can I ask something?
Yes, sure.
Hi, Jeremias, can you hear me?
Sorry?
Can you hear me?
Yes, I can hear you.
Okay. Previously, you said about approval testing. So the ReTest tool use approval testing as a result of test case execution.
Sorry, can you repeat the question slower?
You said previously.
I think here is a micro.
Yes, sorry.
No, sorry.
You said previously that you said something about approval testing.
Yeah, approval testing, yeah.
So ReTest is a tool to do some approval testing. So ReTest is based on approval testing. Or is something way different?
The demo that I showed, the code, that tool that I showed here, is that, sorry, can you, the question was whether approval testing is the same tool as this, or is a different tool, right?
Yes, exactly.
Okay, so this is a different tool. This is a tool that we created. So as I said, we are a startup that want to bring AI into test automation. That want to bring AI into test automation. And for that matter, we need this kind of difference testing, gold master-based testing. And this is a tool that we created that is open source. So you can use that. I can show you. So this is a tool that you can just download from GitHub. and use. And as you just saw, it works. So here, it works by wrapping your driver. So instead of using the Chrome driver, you use the recheck driver. And then at some point, so you say start test, and then you say cap test. These are the only additional methods that you need. And other than that, it creates, and anytime you do something, it creates a golden master. So for any action, so here is after the URL is that one, after sending the keys is that one, after sending those keys is that one, after submitting is that one. Those are the golden masters that are created. And if you now change anything, like I did, like that, it will just give you the differences. And using, let's just run that. It's slow a bit today, I don't know why, sorry about that.
No worries.
So after I run that, it shows me all the differences. So here it says that I just changed from hello there to whatever I typed. And now you can use an advanced, so this is essentially like Git. You can now use, we call it the recheck ignore file. Like git ignore, you can now say what changes you're not interested in, like whitelisting that I told you earlier. So you can, for instance, we ignore the ping attribute, the data attribute, all of those attributes, and you can even ignore like all attributes. You can even say, I don't care about any changes. I want to ignore all attributes and only make sure that my test does not break after I changed those login and name things. And now the test is green, so I changed something, but it executes. So as you can see, the test still executes. So now that ID is not on the HTML anymore, and the name is not on the HTML anymore, but it still executes. And now if I there's a CLI for that. Now I say with recheck, if I apply that change, so executing that, I created a report file. Now if I say commit, those differences will be applied, and then test will fail, because then the ID is not the master anymore. But we can use the ReTest ID. Here it says, for instance, we can use that ReTest ID for that name, whatever. So just that instead of age. So here I have age. Let's say ReTest ID. And now, even if I apply the test, even if I apply the change, the test still won't break. And as you see, the ID completely, like the ID is not there anymore in the HTML. It's completely gone, and I can still address it using the ReTest ID that is in the golden master. So now I can apply the change, it won't break, and that ID, so here's a golden master, it's an example, and that ID is here. No, it's not. It's that one, sorry. No, it's not. What did I do? Yeah, anyway, so here are different retests, like any element is a retest ID, and using that ID, you can reference it, although it might change. Was that the question? Did it answer the question?
Yes, great, thank you.
You're welcome.
Okay, thank you. Someone else? Okay, no one. Jeremy, thank you for your time. I have a last question. What's the plan for the future about ReTest? Depending on new features. Do you have something?
Yes, actually, unfortunately, I don't have a slide for that. So I can show you the slide. But what we are doing, so first we create or we improve on that recheck. So we want to create more. So now we only support Java and Selenium, and we want to support many more. So we want to implement that also for JavaScript and Python and stuff like that. And then at the end of the year, we will release the AI that will then generate the test cases. And those test cases, as you just saw, will then be unbreakable and give you all the differences in the website. So instead of having to specify what you want with an assert, the AI will just execute your software and then generate test cases for that, and after change, you will see what changed.
Great. Awesome.
If you want to know any more about that, you can always go to retest.de. As I said, we're a startup, so this site is currently under construction. And at some point, we will have more information about our AI here as well.
Great. Thank you very much. Applause.
Thank you for having me. It was a pleasure.
Okay, Jeremy, have a nice evening. See you soon.
Thank you. You too. Bye. Enjoy the rest.
Thank you. Bye bye.
Λοιπόν,